Okay, this is part 2 of my suspension steering tutorial, whatever. We already showed you how to do the actual suspension, but now I'm going to just teach you how to wire up the thrusters and the steering anchor. If you're not familiar with what a steering anchor is, it's this piece right here. Basically, rather than attaching hydraulics to the wheels themselves to get them to turn, because there's issues with that, and it wouldn't even work with spindle-less suspension such as this, we are going to attach hydraulics to a plate that turns on its own, and then that's advanced ball socketed to the wheels. This one, there's actually no constraint on it, which isn't the ideal way to do it. We're going to have a constraint, but the one I'm making is just going to be a slight modification of this car, just for simplicity's sake and various other things. Okay, first we'll have to spawn the actual plate that we're going to use as the steering anchor, which is in props, useful and explosive props for PHX, and it's a, I think 0.25 by 1 plate. It's 4 little squares, and we're going to make this thing weigh 100 right now, because if we screwed up the weight so that it didn't support these wheels, which that's actually a different weight, sorry, if we screwed up so it didn't support the wheels, then it would spaz, and we'd have to redo all the hydraulics, because you can't change the weight when hydraulics are on it, unless you want to mess with constants and other things, which we don't want to do. Okay, now we're gonna actually no-collide this to everything, because it doesn't need to be collided to anything, because it doesn't really need to exist. It's gonna be, like, invisible if you want to add, like, parent other things around it and such. It shouldn't really seem like it's there, because on a normal car's operation it wouldn't exist. Then we're going to pull out our easy precision tool, and we're going to use advanced ball socket, have freeze target selected, none of these selected. Then we're going to use a value of X rotation minimum, negative 0.1, maximum 0.1, and then Y rotation minimum, max, negative 0.1, 0.1, and then Z rotation minimum, we want to be about 50, 45. It depends on what you want your minimum turn radius to be, so at 50 it's going to be able to turn 50 degrees left and right. So it won't go any farther than that, so we won't get our wheels like spinning around and stuff, which commonly happens with other types of turning systems. So we're going to have Z rotation minimum, negative 50, and positive 50 for maximum. And then we're just going to go ahead and we're going to have free movement unchecked, because usually that's almost always checked, but we're going to have it unchecked. So it's going to work as basically a limiting axis. And we're just going to grab the plate in the middle and then go ahead and use it on the middle of this, like so. Okay, now we're going to go into our wire tab and we're going to grab our hydraulic tool. Wire hydraulics, so we place one side, then the other side, then the controller. And then we're just going to stick 2 hydraulics. The other one has 4. If you wanted to use 4, you just have to reverse the inputs. It's fairly simple, you can figure that out. Which 4 is important if you're doing like off-road vehicles and stuff, but I'm just going to have 2 right now for the sake of simplicity. They're not going to be fixed. You can use whatever controller model, whatever material. And I'm just going to take 1 and put it to the bottom of the corner right there, and then stick it right here, and then put the controller right there. It's 31.13. And then I'm going to do the exact same thing to the other sides. They both equal about 31.13. The controllers. That's the actual length. This length right here is 31.13 inches, or whatever the unit is in Gary's mod. And now we need to do the actual wiring, which we're going to need a thruster to go forward, obviously, so I'll have that right now. We're just going to add a thruster, make sure bidirectional is on, and force minimum maximum I don't even think really matters. That's just like a multiplier thing. And then, you know, whatever, just copy those values. We'll just use the can thruster, as weights actually do matter to the models. And then we're going to also spawn a pod, or a seat in this case. I'm going to spawn an airboat seat, and I'm just going to put that on the front of the car. Doesn't need to be placed exactly or anything. And then I'm just going to pull out my welding tool from the normal tools menu and just weld that straight to the base plate, which is our chassis. Then we're going to pull out a advanced pod controller, which is the advanced pod controller. Basically, you link it to a pod, and that picks up your keyboard inputs. So, say if you were pressing W while you were in that pod, after placing the pod controller, then the pod controller will output W as equaling 1 as a separate output. It has quite a few outputs. You can look at it with the debugger or whatever if you've never used it before. Don't use the normal pod controller. Make sure you're using the advanced pod controller. The normal pod controller is a different beast entirely, and it sucks. Just don't use it. I've never used it. I learned on the advanced pod controller, only use the advanced pod controller. We'll just stick the advanced pod controller right here, and we'll right click it, and then right click on the pod. It can be anywhere. You can place these controllers anywhere, like any of the chips anywhere, but I'm just going to place them here for simplicity. So you have to right click on the advanced pod controller with the advanced pod controller tool, and then right click on the seat. If you've done wire before, I'm probably boring you, but some people haven't done this. Okay, then we're going to go ahead and we're going to open up our expression 2 in wire and click new expression. Okay, now I'll explain how we do all this. Okay, we're going to want inputs W, A, S, and D, correct? Because we're going to be driving using W, A, S, and D. So we'll type W space A space S, D. W, A, S, and D for our inputs. Those will come off the advanced pod controller. Then outputs, we're going to need a left value for the left hydraulics, and a right value for the right hydraulic, and a thruster value for our thruster. So, since this equals 31.13 is the default value, that's what it equals right now. That's what we want it to default to if we're not pressing any of the turning keys. So, we're going to have left equal 31.13, correct? Because that's what this equals. Yep. And then we're going to have right also equal 31.13. And then we're going to have thruster equals 0. Basically, if these aren't said to equal anything else, then they're going to automatically default to those values. So if we're not pressing A to make that equal whatever value, then it's going to default back to that value, so it'll go back straight when we're not pressing a turn direction. Same with thruster. So let's start with the if statements first. Let's do W first. How are we going to move forward? We're going to, if W is pressed, so if normal parentheses, it has to be normal parentheses around W, and then the curly statement will have a curly bracket, so that's the then. So if W, then what do we want? We want the thruster to equal a value that'll push it forward. So thruster equals, I don't know, 7,000? So that's the if statement. If we're pressing W right now, after we're wiring it, then thruster will equal 7,000. And once we let go, it'll default back to 0. So we need normal, if-then statements always have normal parentheses and then curly parentheses for the then statements. The if statements go in the normal and the then goes in the curly. Okay, now we'll do one for S. So if S, we want the thruster to pull us back, right? So thruster equals negative 5,000, how about? So that's our going backwards, because negative 5,000 will pull us backwards. And that'll also work as our brakes, I suppose. And now we need to do the trickier part, which is the turning, correct? So how would we have this plate turn left if we wanted to go left? We'd have the left hydraulic expand, push this back, and we'd have the right hydraulic retract to pull this in, correct? Yes. So we need to have the left hydraulic retract. On pressing A to turn left, we want the left hydraulic to retract. So how would we do that? We'd make it go down, which let's make it go down by 10. So we'll have left hydraulic will 21.13, and then we'll have right hydraulic expand by 10, so it'll be 41.113. And then we'll do the exact opposite for D, which would be left equals 41.13, and right equals 21.13. So if D, which all that if D means is if D does not equal 0. So it could equal anything, but it's going to equal 1 in this case, because if we're pressing it while we're in the pod, then the pod controller will output a value of 1 for D. But you can also do it, you could also technically write it like equals 1, which would make, if D equals 1, then that happens, or if D does not equal 0, then that happens, but we're just going to do it like this. You could do it anything. This is how you would control anything with an expression if you don't want to use chips. And then we'll just go ahead and we'll stick this expression right here. That's this expression right here. And now we'll go ahead and we'll wire it up. So we'll pull out our Wire Advanced tool, which I only recently started using, and it's a lot easier. And this is our left hydraulic, so we'll wire that value to... Hang on, sorry about that. Okay, apparently I didn't actually put the things in the chip. Hang on a second. We have to write our outputs in here, left, right, and thruster. I don't know how I forgot that. I'm just not used to saying it. So make sure that when you write the expression, you add left, right, and thruster to the output field. Otherwise, it will not have any outputs like that. So that's what these are. These are outputs, these are inputs. So this is going to get an input from the advanced pod controller, and then it's going to output this value. So once you have that next to the output field and input field, you should know at least a little bit about wiring if you're watching this tutorial. Okay, sorry about that. So we're going to wire the left hydraulic to left and the right hydraulic to right, and then we're going to wire the thruster to thruster. And then we need to wire WASD to the WASD value on the pod controller. And this is why advanced wire is useful, because otherwise we'd have to right-click through all these values, which isn't that bad for WASD because they're the first ones, but it also automatically goes to the correct value. So just right-click that, W to W, A to A, S to S, D to D. And that is it. That's literally everything. As long as I remember to link this to the pod, it should work now. But let's add just one more thing. Let's add a nice little e-brake to this thing, which we can use a weld latch for. We'll use a really simple one. It's not gonna like stop automatically or anything. We'll take out our weld constraint latch in wire, and we'll click on the wheel, back wheels, and then click on the base plate, and then hit a controller, and then back wheels. And basically what that does is that makes it that as long as this is engaged, then our it'll have a weld here, and if it does not equal 1, then there will not be a weld here. So all we need to do for wiring our e-brake is wire this straight to the pod controller. So we're going to pull back out our wire advance tool and wire each of these to space, because we want to press space. So space equals 1, and then these will equal 1 because they're wired straight to it. So wire each of these to space on the advanced pod controller. And now let's test it and hope that it doesn't freak out. Advanced Duplicator. Advanced Duplicator 2 is much better than Advanced Duplicator 1. I definitely recommend using that. And look! It has failed! Why is that? Because we forgot our most important part. Correct. We forgot to add our advanced ball sockets to the front. Sorry about that. All that we need to do for that is we take these. You know how we had our wheel settings before where we used an advanced ball socket to put each of these to the base plate? All you need to do is remove the advanced ball sockets you added to the front. If you did, just press R on them, and that'll remove it. So press R when you have the advanced ball socket tool out. Press R on them, and then go in here and make sure that X minimum is negative 180, X maximum is 180, and then negative 0.1, 0.1 for Y and Z. And then just click on that, and then click on the steering prop on the front wheels, and then the steering prop, and then when the steering prop changes, those will change as well. And then let's just go ahead and let's paste this, and those are straight just like they should be, and we're driving. I accidentally swapped the inputs, so I'm pressing D right now to go left and right, but you could fix that by either changing the expression or just switching the outputs, like wire D to A and A to, D on the thing instead. But it's working quite well. Our e-brake's working. Everything's working. Except that I swapped that value. So make sure that if you have your thing swapped, just go ahead and change it yourself. In fact, I'll do it right now just for simplicity's sake. All you need to do is just take out your wire advance tool and go down to, A, and then just wire A to D. This is easier, you don't have to change anything this way. And we'll wire D to A, and it's fixed. That was just my bad. That was a slight oversight by me, because I thought that I installed the hydraulics on the opposite side. But that's no big deal. Anyway, that's literally it. Let's like make a little jump here or something, and just kind of drive over the jump and show the nice suspension in action or something. There we go. Back up. Okay, I'm done. Anyway, hopefully this tutorial was helpful, even though it probably was a little bit confusing, but either way, I'll probably get better at making these tutorials in time. Thanks for watching, and see you some other time.